AI has been around for a while, but it's really now coming into its own because of advances in computing and availability of data. And we know it's got the potential to be transformational in many, many areas. So why are we scared of it? We've had new technology before. Was there this much scrutiny and mistrust from the media, regulators, the public at large, when we were able to have computers in our homes, when the internet took off, or when we got iPhones? I say the answer is no. So why is this the case with AI? And actually, what's with all the blame? If you just look at some of the events over the summer, the A-level grade prediction algorithm, it downgraded 40% of students, and the ones that were most heavily impacted were those from disadvantaged backgrounds. Apparently that was due to a rogue algorithm. The visa decision algorithm, that was taken offline because it was shown to have entrenched racism. That was in August. And last week, the UK passport photo checking app was shown to be biased against darker skinned women. It was 4 times more likely to reject their photographs than those of fairer skinned women. And just thinking about this, I've been doing this a couple of years. And a couple of years ago, when I talk about this, I'd use examples like autonomous vehicles or criminal sentencing systems or predictive policing, which all seemed like, yeah, they're over there, they're far away. But this now all feels a lot closer to home, and it demonstrates the proliferation of AI into the things that surround us. And the impact of this mistrust is that, it's a barrier for deployment, and it's slowing down the growth. So let's unpick this. Why do we not trust AI, and what can we do to build that trust? And I think the starting point here has to be, what makes AI different from more traditional technologies? Well, first of all, it's designed to dynamically learn and evolve its decision framework, which means that you have to continually monitor its outputs to make sure it's doing what you think it's doing. Secondly, it has to be taught and trained by data. And if there's any gaps or bias in that training data, that's eventually going to affect the outcomes. And if you think about the photo checking app, clearly what happened there was that there weren't enough examples of darker skinned women in that training data. Simple, right? Also, AI's decisions are probabilistic, which means that actually sometimes it's going to be wrong. And we have to be really clear about the level and nature of accuracy. And what I mean by the nature of accuracy is, it's no good just saying it's 90% accurate. What does that even mean? Does that mean that for this population of people, it's wrong 10% of the time randomly? Or does it mean for this population of the people, for this 90% here, it's always right? And for this 10% here, it's always wrong? And if that's the case, what are we doing to protect this 10%? Do we understand what inputs it uses and what correlations it makes? And if those introduce some unfairness into what we're doing? And if we look at the exam grading algorithm, it disproportionately affected those from disadvantaged backgrounds. So it must have had postcode or area as one of its inputs. Did the developers know it was working like this? Did the people who were using it know that it was going to do this? Did they put anything in place? I would argue not enough, because it went wrong. And the last point, I guess, in terms of why it's different, is that with AI, the risks aren't just technical, they also cross into ethical and social domains. And in using AI or building AI, you really need to consider the impact that it has on individuals, employees, customers, business partners, and society more broadly, and in turn, what impact that might have on your organization. It's not good enough just to kind of, to just do what's okay from a regulatory perspective, because as we know, and Dr. Ilias has mentioned, this is lagging the technology. And with this real push to use data and to harness that data and, gain some sort of competitive advantage, do something new. We need something to help us navigate what we can and can't do, what we should and shouldn't do. And that's where data ethics comes in. And actually, in terms of kind of building, so that's why AI is different. And we really need to build that trust. That trust is going to be really important if we're going to be successful in using AI. And this diagram just kind of shows that relationship. So the more you can demonstrate trustworthy behaviors, the stronger reputation you build, the more users you get. The more users you have, the more data you get from them. The more data you have, the better insights, improved functionality, more users, etc. So building trust is really important. But how do we build that trust? So commonly accepted conditions to build trust. It's got to be ethical, socially responsible, reliable, and there's got to be accountability. Ethics we've spoken about, Dr. Elias has spoken about. And what we're saying here is, does it comply with social and ethical norms? Is it unfair, unbiased, transparent, and respectful even? From a social responsibility perspective, are you taking into account the impact on human beings, both from a physical, mental, and financial well-being perspective? It has to be reliable. How can you be sure that it's doing what you think it's doing? And what are you doing to ensure that it continues to operate in the way you think it's operating or should operate? And finally, is there a clear kind of line of accountability? Is there a human ultimately responsible for the outcomes? Can you explain what you're doing? Is there something in place for people to be able to identify, challenge, and correct errors? So that's the kind of 4 conditions broadly that you need to build trust. All very theoretical. How do we take this down a level? One of the answers is there's lots and lots of guidelines and frameworks around. One of the more kind of widely known ones is the one that Dr. Elias has just described, which is the European Commission one. And the 3 guiding principles is that they have to be lawful, ethical, robust. And then there's 7 things that sit under there, which is quite eloquently described. But again, it all just feels a little bit kind of theoretical. How do we operationalize this and build this into our day-to-day work with AI? I'll talk you through how we do that at EY. I'm sure there's lots of other people that can tell you different ways, but that's the one that I'm most familiar with because I helped build it. So this is how we think about it. So in the typical development life cycle, you have stages that you have with many other kind of technologies. So from problem identification, working out what it is that you're trying to do, then getting the data in order for you to be able to build that, preparing that data, cleaning it up, etc. Your modeling, training, validation, deployment, and finally monitoring. Throughout that life cycle, there are many, many risks that you have to identify and manage to start to build that trust. Those risks fall into 4 broad areas. So start off with their design risks, data risks, algorithmic risks, and performance risks. So design risks, really understanding what your stakeholders want. Really understanding kind of getting that kind of consensus over what it is they need, but then also getting agreement on how you're going to build that and understanding what's important to them. If we take accuracy as an example, what's more important to them, mitigating false positives or false negatives? Understanding that helps you to build a solution which meets their needs. Understanding the kind of boundary conditions within which it's got to operate and explaining to them the technical kind of limitations. Data risks, making sure that you've got data that is of the right quality, it's unbiased and it's representative. If I'm building something which is going to globally recognize and label wild birds, and I just train it with UK data, it's not going to work very well elsewhere. So really kind of making sure that your data is representative. Algorithmic risks. You can introduce bias at this stage through incorrect or invalid correlations, or you might select an algorithm that doesn't provide you the level of explainability that you need for your particular use case. And also, from an algorithmic perspective, understanding what are you working with, how much data you have, different models, different algorithms need different amounts of training data, take different amounts of time to train, etc. So selecting the right algorithm, and finally performance risk. Just making sure there's no performance drift, it's protected from adversarial attack, and that those limitations of use are understood. So if you have, going back to the bird example, I like the bird example, if you have built something that's just for UK birds, someone doesn't go and use it in Mexico. Okay, so those are the 4 broad areas of risk, but each and every one of those areas kind of splits into many, many different risks, and identifying those risks and managing them appropriately and being able to demonstrate that you've done that starts to build that trust. And in terms of these core principles to build trust, each and every one of those sub-risks mapped to one or more trust principles, which I've shown here. In the interest of time, I won't go through this, but it's kind of the same sort of thing. It's got to be unbiased, resilient, explainable, transparent, and perform as you think it performs. Now, in terms of all the different frameworks that you can use, we've got our principles here, the EU have got theirs, IBM have got theirs, there's many, many different ones, but just to explain to you, ultimately, they all cover the same risks, just different language in different ways. And all this slide does is show you, for example, how the EY framework maps to the EU ethical guidelines. Everywhere there's a green square, we map 1-to-1. Everywhere there's a yellow square, EY's goes into more detail. And everywhere there's a purple square, EY's does more, covers an area that the EU's framework doesn't. So just to finish, I want to leave you this one quote by Stephen Hawking. I'm going to let you read that in your own time, but the bit that I focus on is the last paragraph. I'm an optimist, and I believe that we can create AI for the good of the world, that it can work in harmony with us. We simply need to be aware of the dangers, identify them, employ the best possible practice and management, and prepare for its consequences well in advance. Stop there.